We have already learned about data, which means is a collection of information in the form of numbers. These numbers can be result of surveys, scientific results, or any other collection of information. For example, you can collect the information on run scored by Indian team batsmen in various matches or heights of your classmates. We observe here that these data are very small and easy to understand. You can have bigger data collection also. For example, distance of various planets from Sun, distance between various cities of the world, etc. These data will consist of large number of numbers. This is where we need the important methods mean, median and mode to help us. Now, let us understand what a mean is. Let us see the meaning of the term central tendency. It is a number that best describes a group of data. Central tendency represents or describes an entire group of data with a single number. Here, we have an example of math test scores of a class. In this information, when we calculate the average test score, we find that the average score of the class is 79%. This number, 79, is the measure of central tendency. Thus, central tendency is a single number that represents a group of data. We measure the central tendency using mean, median and mode. Let us study these one by one. Mean. Mean also means average. Both terms have same meaning. Meena works in a candle making factory. She works for different number of hours in different days. Her manager wants to know the average number of candle packs that she produces in a week. Let us see how many candle packs she makes in a week. First day, 1 pack. Second day, 8 packs. Third day, 3 packs. Fourth day, 2 packs. And fifth day, 6 packs. For better understanding, let us represent this data in the form of height of candle packs. 4, 7, 2, 1 and 6. Since the numbers in the data are different, so the height of the boxes are different. What will happen if we rearrange and make the height of all the stacks same? In other words, if each stack has same number of boxes, what would that mean? And what amount would that be? When we rearranged the boxes and made all the stacks equal, we actually found the average number of boxes or the mean. So, the mean of our original data is 4, as we have 4 boxes in each stack. Some of the numbers in the data are more than 4 and some are less. But if the amount of all the numbers in a stack is made same, then the amount would be 4. We know that for every situational problem, it would be difficult to rearrange the boxes or any items and find the amount in each stack. So, we have a method of finding mean. Let us first add up all the numbers, which is like stacking up all the boxes in a line. Adding all the numbers or counting the total number of boxes tells us that we have 20 boxes in all. Next, we count the number of values given in the data. We have data for 5 days. So, we divide the total number of candle boxes by 5 to get 4. So, That's how we find the mean of data. Remember, mean is equal to sum of observations by total number of observations. We will now solve a problem based on mean. Find the mean driving speed for 6 different cars on the same highway. 66 meter per hour, 57 meter per hour, 71 meter per hour, 54 meter per hour, 69 meter per hour, 58 meter per hour. We know mean is equal to sum of observations by total number of observations. Equal to 66 plus 57 plus 71 plus 54 plus 69 plus 58 by 6. This is equal to 375 by 6 equal to 62.5. Thus, mean driving speed is 62.5 meter per hour. Median. Median is the middle of the given data. It is the number that divides the given data into two equal halves. Let us see how to find the median of a given data. For example, we have this data. What would be its mean? The first step of finding the mean is to arrange the data in an ascending order. Now, we can clearly make out that 5 is the middle number. Thus, the median of the given data is 5. It is easy to find the median if the given data is small and simple like this. Just by observation, we can determine the median. What happens when the given data is bigger and complicated like this? We will first arrange the data in order, in ascending or in descending. Once we do that, we count the total number of observations. If the total number of observation is odd, then median is equal to n plus 1 by second term, where n is the total number of observation. If n is even,